Find the sum of m plus n. So we have two complex numbers that we want to add together. So remember that a complex number is made up of two parts. We have a real part and we have an imaginary part. So when we find the sum of two complex numbers, all we're doing is adding the real parts together and adding the imaginary parts together. So if we have 3 plus 4i plus negative 2 minus 3i, the ones that I want to add together would be these two because those are my real parts. So 3 plus negative 2 is 1. And then the other part that I want to add together are these two because those are my two imaginary parts. And so I take 4 plus negative 3i, which is just I, or if you wanted to, you could put 1 on. Both of those would be acceptable. Question 2, solve the following quadratic equation using any method. For this one, I personally would use completing the square, and there's two reasons that I would use completing the square for this one. So number 1, the coefficient in front of x squared is 1. And number 2, the linear term is even. So I'm not going to have any decimals when I divide this in half. So I'll show you both ways. The first way, if we do completing the square, would look like this. So we have x squared minus 4x plus 6 is equal to 0. The first step in completing the square is to move the constant to the other side. And when we do that, we want to leave a space where that constant was, because we've got to make this side a perfect square trinomial. So the way that we do that is we cut this number in half, so half of negative 4 is negative 2, and then we square that number. And so when we square that number, we get positive 4, which is why this is always a plus here. So the next step then is to take this piece right here and rewrite it as a factored perfect square trinomial. So we're going to take x, and then we take half of this number right here and put it down here. So half of negative 4 is negative 2, and then we're going to add these two together. So negative 6 plus 4 is equal to negative 2. The next step in the process is we need to undo this squaring here. So we're going to take the square root on both sides. And when we take the square root on both sides, we have to remember this plus or minus here. So now we have x minus 2 is equal to positive and negative square root of negative 2. So before we do the next step, we have a negative underneath this radical sign. So to get rid of that negative, because we only want positives underneath the radical sign, we're going to change this negative 2 into a positive 2. And when we do that, we have to bring the I out. The last step then is to add 2 to both sides so that we can get x completely by itself. And so we end up with x is equal to positive 2 plus or minus I times the square root of 2. Now, if we do this using the quadratic formula, we'll get the same answer. It's just a different way to get it. So the quadratic formula, remember, is x equals opposite of b plus or minus the square root of b squared minus 4ac, and it's the whole side that's over 2a. It's not just the radical that's over 2a. The negative b, the opposite of b, also has to be over that. So where do we get a, b, and c from? Well, a, b, and c come from the coefficients and the constant, and we have to remember to include those signs. So a for this is equal to 1. B is equal to -4 and C is equal to 6. So all we have to do is substitute these into this and then simplify. So remember, this just means the opposite of B. So if this B is -4, when we put it into the equation, it's +4. So +4 plus or minus, and you'll notice we have a plus or minus here. We have a plus or minus here. Square root of B is -4, so -4 squared minus 4 times 1 times 6, all over 2 times 1. So we have 4 plus or minus the square root. Now we have 4 squared is 16, and 4 times 1 times 6 is 24. So we have 16 minus 24, which is -8. And we have this over 2. So again, we have a negative under our radical sign. So we have 4 plus or minus I. And then the square root of 8, we have to make sure that we simplify this radical. So the square root of 8 has a perfect square factor, which is 4. So the square root of 4 and the square root of 2. The square root of 4 is 2, and the square root of 2 we leave alone. So notice when you take the square root of a number, you actually just put the number. You don't use the radical sign anymore. So we have 2 square root of 2 over 2. So the last step now is that we want to look at these 3 numbers here, and we want to reduce them like we would normally reduce a fraction. Well, 4 divided by 2 is 2. 2 divided by 2 is 1, so I can write that or not. But you notice that the answer that we get for this is exactly the same as the answer that we had for completing the square. So both of them will give you the same result. You just have to decide which one you feel more comfortable with. Next question. Again, solve the following quadratic equation using any method. In this one, we're really kind of forced into one method because of this right here. So that 3 is basically going to force us into using the quadratic formula. So we have x is equal to the opposite of b plus or minus the square root b squared minus 4ac, and the whole side is over 2a, not just the radical part. The whole side has to be divided by 2 times a. So a, b, and c, again, come from the coefficients and the constant in our quadratic equation. So a is 3, b is 1, c is -6. So we're just going to substitute those into the formula and then simplify. So b is 1. When we plug it in, remember this is the opposite of b. So this would be -1 plus or minus the square root of 1 squared minus 4 times 3 times -6. So 1 squared is 1, and 4 times 3 is 12. 12 times 6 is -72. So we have minus a -72, which is going to turn into 1 plus 72. And then this is all over 2 times 3. So x is equal to -1 plus or minus the square root of 73, and then the whole thing is over 6. Now I'm not going to be able to simplify this any farther because 73 is a prime number, and I can't simplify just these two and not these two as well, but these coefficients here are both 1, so this is as simplified as this answer gets. Question 4, find the difference of m minus n. So again, difference this time means subtraction. So same concept, we're going to be subtracting these two instead of adding this time though. So we have m is equal to, sorry, I'm going to start that over again. I have m is 3 plus 4i and n is -2 minus 3i. So if I'm subtracting, I have 3 plus 4i minus -2 minus 3i. So when we have a negative, when we're subtracting here, we want to take this and treat it like a -1. Multiply it through. So -1 times -2 is +2, and -1 times -3 is +3. And once I change these, this one now is going to change to addition. The first complex number is going to stay exactly like it was. It does not change at all. And now all we have to do is just what we did before. We're going to add the real pieces together. So we have 3 plus 2, which is 5, and 4 plus 3, which is 7. And since that's the imaginary part, we need to keep this I. Question 5, solve the following quadratic equation using any method. Looking at this one, because I have a 1 as the coefficient here and this is even, I'm only going to solve this one using completing the square. You're welcome to use the quadratic formula and check to see that you get the same answer. So I'm going to do complete the square. So we have x squared minus 10x minus 6 is equal to 0. So the first step, anytime you're completing the square, is to move the constant over to the other side. And the reason that we do that is because we need to make sure that this side is a perfect square trinomial so we can write it in factored form. So we have x squared minus 10x plus something is equal to 6 plus something, because whatever we add to one side, we have to add to the other. And it's always going to be addition. Because when you square something, you get a positive. So the way that we get what goes into this blank is by cutting this number in half. So when we take -10 and cut it in half, we get -5. And then we square that, which is 25. And now we're going to take this side and we're going to write it in factored form. So we take this number and cut it in half and put it after this right here. So half of -10 is -5, and 6 plus 25, we just add these two together, which is 31. So next step is to take the square root on both sides, and when we take the square root, we have to remember to do plus or minus. So this part is going to cancel out, and on the left-hand side, we get x minus 5 is equal to, and on the right-hand side, you get the positive or negative square root of 31. This is a positive, so I don't have any i's that I need to take out, and 31 also is a prime number, so it doesn't have any factors that are perfect squares, so I can't simplify this side any farther. So the last step is just to move this 5 over to the other side. And when we do that, the solution that we get is x is equal to 5 plus or minus the square root of 31. Question 6, how many solutions does x squared plus 5x minus 4 equals 0 have? So the first thing that we want to do is we want to use the discriminant to figure out whether it's going to be positive, negative, or 0, because that's going to tell us how many solutions and what kind of solutions they're going to be. So remember, the discriminant is b squared minus 4ac. It's the part that's underneath the radical sign in the quadratic formula. And we get a, b, and c from the coefficients and the constant in the quadratic equation. So a is going to be 1, b is going to be 5, and c is going to be -4. So we just have to substitute those in and then simplify. So b squared would be 5 squared minus 4 times 1 times -4. So 4 times 1 times -4 is -16, and we're subtracting that. So when we have minus and negative, that becomes a positive. And then 5 squared is 25. So 25 plus 16 is 41. Since the discriminant is positive, that means that we are going to have two solutions. And anytime that it's a positive, we know that those solutions are going to be real solutions. Find the product of m times n. So here's the complex number m, and here is the complex number n. And so we're just going to multiply these together. And we're going to use the area method. So 3 plus 4i and negative 2 minus 3i. And we're just going to multiply. So negative 2 times 3 is negative 6. Negative 2 times 4i is negative 8i. And now we're going to do the same thing with negative 3i. We're going to distribute that to both of these terms up here. So negative 3i times 3 is negative 9i. And negative 3i times 4i is negative 12i squared. Remember that I squared is the same thing as negative 1. So really what happens with this one is the I squared goes away and the negative 12 becomes a positive 12. And all we have to do from here is just combine the real parts and the imaginary parts and write our answer as a complex number. So negative 6 plus 12 is positive 6, and negative 9i plus a negative 8i is negative 17i. How many solutions? So remember that solutions means how many times does this cross the x-axis? Well, it doesn't cross the x-axis at all, which tells us that we are going to have imaginary solutions. And anytime that we have imaginary solutions, we always have 2. So we have 2 imaginary solutions because the graph does not cross the x-axis in any location. Solve the following quadratic equation using any method. Because of the 2 here on the quadratic term, we are going to use the quadratic formula. So remember that the quadratic formula, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, and the whole side over here is divided by 2a. So remember, a, b, and c come from the coefficients and the constant in the quadratic equation. So a is equal to 2, b is equal to 5, and c is equal to negative 4. So x is equal to the opposite of b. B is 5, so the opposite of b would be negative 5, plus or minus the square root of, so b is 5, so 5 squared is 25, minus 4 times a times c, which is negative 4. So when we multiply these 3 together, 4 times 2 is 8, 8 times negative 4 is negative 32. So this is going to actually turn into be a positive because we're subtracting a negative. And then this is 2 times 2 in the denominator. So we're just going to write our simplified answer. Negative 5 plus or minus the square root of, so now this is 25 plus 32, because 4 times 2 times negative 4 is negative 32. So we're subtracting a negative 32, which turns into positive. And then this is divided by 4. So simplify what's underneath the radical. Negative 5 plus or minus the square root of 57 divided by 4. This is the simplified version. I can't do anything else because 57 is a prime number. I don't have any, sorry, not a prime number, but it doesn't have any factors that are perfect squares. And I can't simplify the 5 and the 4. I don't have any factors in common. So this is the correct answer. How many solutions does x squared plus 4x plus 8 equals 0 have? Again, we want to use the discriminant. So the discriminant is b squared minus 4 times a times c. And we get a, b, and c from the coefficients and the constant in the quadratic equation. So a is 1, b is 4, c is 8. So we just substitute these values into this discriminant and then simplify. So 4 squared minus 4 times 1 times 8. 4 squared is 16. 4 times 1 is 4. 4 times 8 is 32. So we're subtracting 32, which gives us a negative 16. Whenever the discriminant is negative, it means that we are going to have two solutions that are both imaginary. Find n squared. Remember that when you square something, you're multiplying it times itself. You're not just squaring each of the individual pieces. So n squared would be the same thing as negative 2 minus 3i times negative 2 minus 3i. So if we use the area model again, negative 2 minus 3i goes here, negative 2 minus 3i goes here, and we just distribute each one of these here. So negative 2 times negative 2 is 4. Negative 2 times negative 3i is positive 6i. And then we do the same thing with negative 3. Negative 3i times negative 2 is positive 6i. And negative 3i times negative 3i is positive 9i squared. And remember that the I squared is the same thing as multiplying by negative 1. So we take this off and we change the sign on the number to its opposite. And now we just combine our like terms. So we put the real parts together. So 4 minus 9 is negative 5. And we put the imaginary parts together, which is positive 12i. Solve the following quadratic equation using any method. Because of the 3 here, we're going to use the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac. And the whole side is divided by 2a. So remember, a, b, and c come from the constants, the coefficients, and the constant. So a is 3, b is negative 4, and c is positive 2. So x is equal to the opposite of b. So if b is negative 4, the opposite of b is positive 4, plus or minus the square root of b squared, which is 16, minus 4 times 3 times 2, all over 2 times 3. So we're just going to simplify this. So 4 plus or minus the square root of 16. So 4 times 3 is 12. 12 times 2 is 24. So we're doing 16 minus 24 over 6. X is equal to 4 plus or minus the square root of negative 8 over 6. So I'm going to move this up here. When we take the square root of a negative number, remember that's where we get our i's. So this is positive 4 plus or minus I. And then the square root of 8 has a factor that's a perfect square. So this is the square root of 4 times the square root of 2. This is 2. This is the square root of 2. So we're going to replace the square root of 8 with this. And it's all being divided by 6. I'm going to rewrite this really quickly here. So we get 2i. And then I want to simplify. So all of these can be reduced. So I can divide all of these by 2. So x is equal to 2 plus or minus. You can leave this as 1 or you can leave it out. I square root of 2 over 3. How many solutions? So remember that solutions means how many times does it cross the x-axis. So we have crossing the x-axis in 2 places, and any time that it crosses the x-axis, it means that those solutions are real. So we have 2 real solutions for this one. Solve the following quadratic equation using any method. Because the coefficient here is 1 and this is an even, I'm going to use completing the square. Okay, so we have x squared minus 8x plus 16 is equal to 0. So remember the first step when we complete the square is that we want to subtract the constant or move the constant from one side to the other. So we get x squared minus 8x plus something is equal to negative 16 plus something. We want to leave this blank here because we want this side to be a perfect square trinomial. So the way that we get this number here is we cut this number in half and square it. So 8 cut in half is negative 4. Negative 4 squared is 16. So whatever we add to one side, we have to add to the other. So we're gonna factor this now. So x minus 4 squared. This number comes from half of this number. And now we're just going to add these two together. So negative 16 plus 16 is 0. And we're going to take the square root on both sides because we need to get rid of our 2 here. And the square root of 0 is just 0. It doesn't have a positive or negative. So we don't have to put the plus or minus if we're taking the square root of 0. And we have x minus 4. And the last step is just to add 4 to both sides. So we're going to add 4 here, add 4 here, so we get x is equal to 4. Question 15, write the complex number for point A. Explain your thinking. So the complex number here is similar to an ordered pair. It's just that this represents the real axis. This represents our imaginary axis. And so in order to figure out what A is, we need to go all the way over to 3 on the real axis. And then because we're going down, that means that the negative part, the imaginary part is actually going to be negative. So this is negative 1, 2, 3, 4. So we would write that as 3 minus 4i. And then this is for A. Now, if we were going to do B, it would be similar. So for B, instead of going to the right on the real axis, we're going left. And so left on the real axis means a negative number. So that would be negative 2. And then because B is above the real axis, then that means that our imaginary portion is going to be positive. So this would be plus 1, 2, 3, 4i. And that is for B. And I realize that this only is asking you to write the complex number for point A, but just so you have some practice with both. The signs for your real and your imaginary portions are going to be the same as they would for the quadrants if you were writing down an ordered pair. So in the first quadrant, both your real and your imaginary are going to be positive. In the second quadrant, your real will be negative and your imaginary will be positive. In the third quadrant, both your real and your imaginary will be negative. And in the fourth quadrant, your real will be positive and your imaginary will be negative. And the last one, how many solutions does x squared plus 6x plus 12 have? So again, we want to use the discriminant for this, which is b squared minus 4 times a times c. And a, b, and c come from the coefficients and the constant in our quadratic equation. So a is equal to 1, b is equal to 6, and c is equal to 12. So we substitute those into the discriminant and solve. So b is 6, so 6 squared is 36, minus 4 times 1 times 12. 4 times 1 is 4. 4 times 12 is 48, so we're subtracting 48. And so we're going to get a negative number, negative 12. And because the discriminant is negative, that means that we are going to have 2 solutions, but they are going to both be imaginary solutions.